Hi, and welcome again. As you know, my name is Wim, and I'm here to uh, present you Paul Dragoonis, who's going to talk about the future of continuous delivery. If you look at Paul's bio, you can see that he is working in more working groups than he has time to even explain in this session what all those working groups are. I'm very curious what he would like is going to tell us about the future of continuous delivery because it's a hot topic nowadays, and I'm wondering which way we are heading to. Paul, the floor is all yours.
Thank you, Wim. Hopefully everybody can see my screen okay. Technology is working, and I hope you can understand me okay as well. As mentioned, I'm Paul. I'm from Scotland, and I am going to be talking to you about continuous delivery. My talk is structured into three parts: the past, the present, and the future. So the past is very quick. We're going to cover that very briefly and spend more time and attention on the other parts of the topics. The past is important because it tells us why we are here today and how we got here, and not by luck and not by chance, but through methodical changes that have happened over the years to land us and for us to arrive at this present time. Very brief introduction about myself. For those of you who haven't met me or heard of me before, I am an open source contributor. That's pretty much a big part of my life, has been for a long time. I am part of some open source projects such as PHP, Jenkins, and the PHP Fig, which is the standards body. Also part of the CD Foundation, which is kind of like the CNCF, which is the Cloud Native Compute Foundation. So it's both part of the Linux Foundation, and they are kind of sister groups or sister organizations that the CD Foundation is basically taking the CNCF work, or the cloud native things in the cloud native ecosystem, and working and developing on these things with a focus. It's cloud native, but with a focus on CD. I'll also organize conferences, tech conferences, and I'm obviously I'm a speaker and I'm a trainer and do workshops privately and publicly. And I'm very much focused on CI/CD, quality, software engineering, test engineering, all that kind of everything. But the whole package, up, down, left, and right. These are just some job titles I have in my career. I'm basically a principal level engineer and architect, and I work as head of engineering and CTO and stuff like that as well. And I spend a lot of my time on CI/CD. The reason I specialize in CI/CD as a consultant, have done, is because if you have great software, that's fine. And if you have great infrastructure, that's fine as well. You have great tests, that's great. But if your CI/CD system and your processes are not great, then it's all for nothing, because CI and CD are the central points of an organization, of a team, or the teams, and they're all flowing in and out of a central place. And so I would spend my time fixing the software, but then the CI/CD part wasn't very great, and so I felt like I would invest heavily in that so that it could, fix the bottlenecks of organizations, quality, and speed and things like that. Despite all of these things, this is me every day. I'm still learning, and these are the two states of what I go through on a daily basis, and I hope that you feel the same way. I'm now a CEO, CTO. I start my own startup. We are a technology business, and we are hiring. So it's effectively kind of like recruitment, but for engineering. So we're an engineering company, and we help other companies hire staff and temporary workers. So it's at dragoonis.com. You're welcome to go check it out. And basically, my engineering team takes the pressure off of your engineering team when it comes to hiring. So anyway, that's the short version of it. Check out more if you're interested. Moving on to the CD Foundation. Like I said, it's part of the Linux Foundation, and it's part of this. Is next to the CNCF. Is the CD Foundation has projects inside of it. So the CNCF, which is already established, has projects like Kubernetes, Flux, and Keptn. You'll hear more about those top technologies later in the talk, about Keptn and Flux. And the CD Foundation has some projects in that right now, such as Tekton, such as Jenkins X. If anyone has any questions at any point throughout the talk, please put them into the chat as and when you think of these questions. And what we'll do is at the end we'll go through all these. But if you think of a question, don't try to remember it. Just write it down and get it out there, and then we can discuss things at the end. So onto the main talk. The past. How did we get here? So this is for the past 20 or 30 years. This is what software development has looked like, and specifically with the web as well. And that's been fine. It's not really been a big problem, and it's not caused as many issues. And doing CI pipelines has also been very straightforward. You have one repository and you have one pipeline, and you just have steps A, B, C, D, E. All right. Life was simple, predictable, and stable. However, now in modern times, maybe for the past 8 years, 9 years, globally, software companies are delivering more and more software than ever before, and this has put unprecedented demand upon businesses and challenges upon organizations and engineers, testers, DevOps people, software developers to create CI/CD solutions that were tailored to the modern world. And so we transitioned from, on the left side, from monolithic to microservice, which is distributed systems, right? And the reason we had to do that is because the scale and the volume of traffic and of consumers and users and systems on the internet is growing and growing exponentially to the point where having one monolithic application no longer was fit for purpose, and therefore we decided to move to a more distributed systems architecture in life, right? And that ultimately that is the shift of the industry, which ultimately affects everything, including things like CI and CD. So we went from something simple to something like this, right? Because there was no plan. There was no way to take Jenkins, for example, take a single Jenkins pipeline and be able to, now you have not one application, but you have 10, or you have 20 applications, or you have 15 applications, and they have dependencies on each other. And it's really became the Wild West. This is an example of a pipeline that I created for the UK government when working as a consultant. So effectively, this is also monolithic, but it looks different. And this was a pipeline that took 1.5 hours to complete, and I got that down to about 12 minutes using my techniques and my experience in developing CI systems. And so it's with that experience and with this insight that I'm able to get talking to you about this. So the challenges of moving from monolithic to micro, right, architectures is the pipeline development became really complex. Sharing code between pipelines became necessary because you've got 20, 30 applications, but their CI pipelines may do similar things, right? Or the CD pipelines have done similar things. So rather than cloning that, we got to try to share it. But there was no rules for that. And at the moment, at the time, maybe 5 years, 6, 7, 10 years ago, everyone is using Jenkins, basically, right? The majority of the world was using Jenkins. And so there was no, Jenkins were not really designed for that, right? For at least the community, we created Jenkins, right? For us, for ourselves. But things changed and it was no longer fit for purpose. And so we entered into the Wild Wild West of CI/CD. And there what happened is some private companies led the way for how to do CI/CD, how to do it in Jenkins, how to do it with Docker. So some companies is like Weaveworks and CodeFresh who were advocating, how they do CI/CD, how best practices work, how to structure your pipelines, how to do all that. And so people were emulating them. What people were trying to copy them. The challenge was those companies are large, are very, very large. Maybe they have 100 applications or 200 or 300 applications. And so the things that they're doing not really fit for purpose for most people's businesses because maybe we only have 2 applications or 5 or 10, right? Or services, and that's okay. So there was a little bit of a gap between what was being advocated and how to do it, and what was the best practice versus what was practical for us. And so it didn't quite hit the nail on the head. So next came private sector companies such as Circle CI, GitLab, and Bitbucket as examples. And they used money, capital investment to create some solutions to try to lead the way in terms of designing solutions that are out of the box and they are ready for a distributed systems architecture, compared to the other ones before that, which were not designed for that. And the problem with these systems is they're proprietary, they're closed source, they're very primitive, and they're general purpose tools. And ultimately, you're not in control. You're only in control of what these companies allow you to do because they're giving you a YAML file, and that's it. Compared to, say, with Jenkins, where you have full control of doing, everything you want, right, and changing everything and anything you want because it's open source and it's your system. So the reason that this is a problem with being general purpose, like these applications, Circle CI and others, are general purpose, and the problem with that is that because they have limitations to how they work, and they can only have certain amount of ways that you can customize them, and that's it. You're out of luck afterwards. Teams have to start then adjusting their processes around what the tool will actually allow them to do. Whereas in actual fact, what it should be is that the CI and CD solutions should be a organic and natural reflection of your organization. And so we had that before, where the pipelines were developed against how we work as an organization, but now people are having to change their processes. Oh, you cannot do that with this tool, or you cannot do that with this tool. So we're going to have to change how we deploy and how we test and how we do things because we're working around a confined environment, which we cannot really change so much. And so that's the kind of the pros and the cons of, the general purpose proprietary systems, and not, right. There's pros and there's cons, of course. And that's kind of where we got to, right? And that's where we are today, in effect, right? How we got to here and why we got here. And around 6 or 7 years ago, something happened. There was a trigger of innovation. Now, the trigger of innovation prior to that was cloud native software, containerization, Docker for starters, and also Kubernetes, meaning that you can build something once and it can run on any cluster, on any Kubernetes cluster, on any cloud ever, right? And that's very powerful. Now that existed, but no one was really solving CI or CD problems using cloud native technologies until Tekton. So Tekton, around 4 to 5 years ago, the open source community, they innovated with a cloud native focus, and they said, you know what? If we're building all this great technology, cloud native technology for the clusters and for the applications and everything, why couldn't we repurpose this for CD? And then that's what Tekton was all about. And this is an example of Tekton. It's cloud native, it's agnostic, it's a big YAML file with lots of stuff in it. And you create a pipeline with tasks and pods, and it's standard stuff. But it's all completely cloud native. So you can put it on, you can take your pipeline and move it to any cluster, right? The challenges were it was very bare bones, very, very verbose. And so trying to build something in Tekton is very challenging because it's just loads and loads of YAML files. It's not very abstract, right? But it works. It's that people are still using it in production today, and it serves a purpose, right? Which you have a container and something happens inside that container. And so that was Tekton, and that's what triggered that, and that's what made the whole world think about, hey, actually, you know what? What more could we do? If Tekton is doing it at a very basic level, surely we could do better. Surely we can take what we had in the past, open source, and we could bring it into cloud native. And that's effectively what the CD Foundation focus is all about. And now, which is the present time, these are some of the tools that we have in the industry and that you have to be able to bring into your organizations by yourself with maybe some support from some DevOps or infrastructure people to help you set things up. But all the goodies are now here. And when people, and although we call it the present, I feel like this is the future, right? And the talk is called the futures of continuous delivery because actually we're living in the future right now. If you go back 2 months ago or 6 months ago, and we thought, or 12 months ago, and we're like, oh, in the future, we don't have these things. And now we do. So effectively today we are living in the future, but not many people are taking advantage of what we now have. So the innovations we have today that are stable and they're being, in use for years now, these are some examples where you should check out and research further, look at blog posts, set it up, and start to take advantage of all of the things that they give us for free open source and full control again. So it's the balance between what we had. We had Jenkins, which is, fully full control, but not ready for microservices and stuff. And then we have closed source systems, which have their cons as well. So now the community of open source is coming full circle, and this is where we are today. So definitely check these out, and we're going to focus on a few of these tools as well throughout the talk. One of the things is about GitOps. So GitOps is not a tool, it's a methodology, and it's a new technique that's came out recently in the industry to allow us to manage the complexity and the configuration of different applications. Because before we only had one application to deploy, a monolith, now we have 10. And so if you have 5 environments, you have production, maybe staging, and then some feature environments, some testing environments, and so on. And so by being able to firstly know, so you know what the systems should know what application, and more specifically which versions of the applications should be on which environment. And sometimes that was one of the complexities that we faced as a community when transitioning. I've got 10 containers now, but I don't know which versions of these containers are running and which environments, and how to ensure that they're always running those right versions. And so, about 12 months ago, GitOps became very popular, and so I'm confident that many people in the audience listening right now will have heard of GitOps or have used it or be familiar. But for those of you who have not, that's effectively what it is. And you basically say you just push code to a repo with the versions of things, and then something else is listening. And in this case, it's Argo CD that's listening on this image. And then Argo will take the changes you've made, and then it will, make that happen on the deployment side. So the next tool I'm going to feature is Jenkins X. So Jenkins X is kind of what Jenkins was not, right? I mean, Jenkins is not the same as Jenkins. Jenkins and Jenkins X are very different. They're solving different problems, and they were created at different times. Jenkins X is maybe 2 years now in development, being used in production by some companies. Jenkins X is fully cloud native. It runs on any Kubernetes cluster, period. And it's an opinionated, out-of-the-box solution, but it's with using cloud-native tech. And to give you an example of something that it gives you for free, here is a preview environment. So this is something that organizations need badly, and they don't always have it because it's hard to set up. Jenkins X, for example, gives you this preview environments and loads of free stuff out of the box. And ultimately, it gives you so much good stuff for free straight away and manages it all, and it's got pre-configured files that you can then customize things. You can turn things off that you don't need, or you can change and adapt them because it's still open source, but it's like a solution now. Whereas Jenkins in the past was more like kind of build things together, put them all together yourself, and it's fantastic, but it takes time and effort. Whereas Jenkins X obviously is coming in with, here's everything for free. Whatever you don't need, turn it off, or whatever you want to change, just configure it. And so to give an example, a preview environment, when you create a pull request, it will automatically, in the cluster, because it's cloud native now, there's no real hardware, no real VMs, that it can create subdomains for each of your pull requests. So like pr1.preview.company.com, pr2, pr3, pr4, and so without even lifting a finger, if you push to a branch and make a pull request, Jenkins is going to be listening for that. Jenkins X is going to be listening for that. And it's going to do things with that, which is, in this case, it will create you an environment for you automatically. And then it will also, once it's created, it's asynchronous. So once it realizes you made a pull request, it will put a comment onto your pull request for you to say, hello, I am the Jenkins X bot. You have a preview environment available now for use. And then there's a link and you click it and boom. And so like that stuff that you have to build, right? That's stuff that you still have to put in place together. If you're using things like GitHub Actions or whatever like that, they're good for CI, but that's only one small part. It's just a pipeline. You've got all these other things going on about your organization, your application. Then that's where things like Jenkins X and Argo will be a superior option for your organization than something quite basic like GitHub Actions, right? Jenkins X can be installed on any existing Kubernetes cluster. So if you have a cluster already, you're already paying money for that, and then you could just on the command line, you just say Jenkins go, give it the credentials for your cluster, and boom, it will install itself on the cluster. And if you can also easily uninstall from the cluster. So if you don't want it, it's very clean because it's just containers at the end of the day in configuration, which can be created and also deleted. And if you do not have a Kubernetes cluster, Jenkins X will make one for you. And so it's very clever. It's a full solution. So if you just have your Amazon credentials just on your command line ready, and you say, "Hey, Jenkins X, install yourself," and it will say, "Well, I don't have a cluster," and you can go, "That's fine. Go make one, please." And it will go on Amazon, and it will make the cluster and install itself and configure itself on the cluster without you having to do much apart from just put in your credentials, and boom, you've got a full system. And so Jenkins X is not as mature as the other systems like Argo or Spinnaker or Flux, but it is very, very viable tool right now, and I highly recommend you check out blogs and the internet. Right now, on this diagram, which is a diagram around Jenkins X itself, which is really just lots of Kubernetes magic and cloud native cool stuff. On the right hand side, you can see it's got environments. So we no longer need more servers or more machines. It's just a namespace in Kubernetes, which is free. It's just a label at the end of the day. So if you want to create more environments, you tell Jenkins X that in the config, and it'll do it. And you won't even have to think about it. It's just done for you. So that's great. On the left hand side, you can see things like user interfaces. So the Jenkins X API is there. And now you may be familiar with the old classic Jenkins user interface, and Jenkins has a new interface on the old Jenkins called Blue Ocean, which is a tool that I was working on and be part of on Blue Ocean. So it was a nicer interface to Jenkins, but still not quite there. So of course, it being cloud native and all container based, what we have now is basically the user interface is completely isolated and separate from the actual engine, the mechanism itself. And so if you go online right now, you can go and install any interface you like. There's great interfaces that are being developed by people, and my point is you're not limited to just one interface now, right? With, like, say you were with Jenkins or you were with GitHub Actions or whatever. There's just interfaces now with all the great features and options and stuff. And of course, it's open source, so you can change the interface. You can add things to the interface. So imagine you have an organization that you need to know about things, or you want to lay things out, or you want to have certain terminology or anything. You can take an interface, you can clone it. It's probably created in React.js or React.js or something that so now your organization can have its own custom control panel for your system. So that's a very powerful thing to have. And so again, Jenkins X, it's out of the box solution. It's got everything you need, and you can turn things off and you can change things as and when you need it because it's open source. So that's all I have to say about Jenkins X. Next, we're going to talk about Flux. And again, if anyone's got any questions around, if anyone's got any questions around like anything I'm saying so far, remember you can drop the comments in the chat and as you go, and then we can pick it up later. And so onwards to Flux. Flux CD is got good community support. It's in production for a few years now, maybe 3 years, maybe 4 maximum. And it's very, very good, and it's got very deep integrations with Kubernetes. It literally is built using cloud native tech. Flux CD is created using the same tech that Kubernetes is created with, effectively. So they're speaking the same language. And as such, you get very deep integrations with behavior of how to control things, how to control actions that are in your cluster that Flux can be aware of. Kubernetes in itself is an event-driven architecture and an event-based system. So everything that's happening on your cloud in real time, whether that's staging or production, or whether it's on your CI or CD kind of jobs or whatever's going on, it's always monitoring things. You can always check the events and analyze the data, everything around Kubernetes. And so Flux speaks the same language as Kubernetes, so it can analyze and monitor and be aware of things at quite a deep level compared to other solutions that are not like that. Okay, so if you've the point of this slide is just if you've not heard of Flux before, go and check it out. If you're already using Docker containers, then this is going to be a good natural fit because it's cloud native container based. If you're already using Kubernetes, this you can just plug this on and it will just give you so much good stuff. It's not as it's not a fancy as a fancy solution as Argo CD or Spinnaker or Jenkins X, but it is good and it's strong in what it does. It does one job and it does it really well, and so that's why I'm highlighting this. And so again, we've innovated as a community. Now you have Flux. Go and check it out. You can install it on any cluster. So on your local machines, we have clusters now, right? It used to be called Minikube, which is like a mini Kubernetes cluster that you can run on your machine, but that wasn't very good. Now these days we've got really good localized clusters that you can play around with. So like a K3S, rather than K8S, which is the Kubernetes word, K3S is a kind of a mini version of the Kubernetes cluster, and you can install that on your local machine. And when you have K3S as an example, then you can just play around and install whatever you want and uninstall it whenever you need. So it's easy these days to try things out without needing access to systems and have lots of problems, right? So we're in a good space now. Next, I want to focus on Argo. Argo is probably one of the most popular tools in the modern age now in terms of the CD tool. And so I'm going to give a little bit of a highlight to this. So Argo is not a project; it's an umbrella of many projects. First and foremost, and Argo has things called workflows. We used to call them pipelines. Now we call them workflows. That'll make more sense later into the talk because I'll talk about the future. Right, we're still kind of in the present at the moment. GitHub Actions also has they call them workflows as well. So there's a trend happening, and again that's why I'm trying to make you aware of the trends and where we were, where we are. Argo has something called Argo Events, which we're going to focus on at the end of the talk because that's about the future. But it has things. But Argo is a fully blown solution, so it has everything that you could think that Jenkins X would bring to the table. It has everything that Flux and Spinnaker and others. And so ultimately, it is a full system. So if you're needing confidence in a solution for your business that's modern, that understands containers and understands distributed systems, Argo is a fantastic choice. And they are advocates of best practices. For example, like GitOps, where anything that is important to the industry, anything that's being driven. So there's what we're driving in the industry, we're moving to events, and we're using things like GitOps. So when you've installed Argo from the beginning, it's going to be best practices, and that's my point. They are advocates of best practice. So like by default, it's going to work with GitOps. So if you've never used it before, it doesn't matter. You're going to get GitOps whether you like it or not. Yeah, sure, you could probably turn it off and it would work in a different way, but they're kind of putting everything that's innovative, it's right there for you in the latest release of Argo workflows every time. Bam. And so it's going to be a good home for yourself and your teams to have, because anything that comes out of the community that's good, Argo's going to have their own solution for that or their own thing, and they're going to bring that into that world. So it's very stable and a very good choice though, and that's that. On to a next tool we're featuring called Captain, right? So Captain, I gave this talk at a conference live 3 weeks ago in Scotland at Cube Huddle conference, and everybody in the audience, I was saying, hey, have you heard of Tecton? Have you heard of Flux? Have you heard of Argo, etc.? And some people, different numbers of hands. And when I asked about Captain, nobody really had heard of it. And I was like, wow, good. This is great value I'm adding now because no one's heard of it, and you really need to know about this tool. So Captain, similar to the Argos and the Fluxes, but it solves it brings a different purpose to the landscape. So Captain is not yet another Argo, yet another Jenkins X or CD tool, right? It's different, and I'll explain this. So Captain is what we call a control plane, like a command center for all of your environments, like production, staging, etc., all your different environments. But what it does is it manages the full life cycle of your applications and services a lot more than what the current tools are doing. The current tools are doing, 95% of all the job, but Kepton pushes that to a wider context, and you'll see that on the next slides. And it also acts as an umbrella around the other tooling. So Kepton is not a replacement for your existing tooling. It's an umbrella that will wrap around them, and it will allow you to bring your own stuff into Kepton land. So if you have something already, such as GitHub Actions, CI pipeline, or Flux or Argo CD pipelines, you don't have to change them, because Kepton, when it wraps around them, will communicate to your Argo or to your GitHub Actions, and so it understands, using APIs, it triggers and talks and communicates to all the different systems under the hood. And so that's what I mean with when I say integrating other systems into a central place. And this is where things get different to other tools. Kepton integrates monitoring and observability tooling. And the way they do that and how they do that is very, very different to other tools on the market, which don't really cover this aspect as well. Here's an image from Kepton. It's just different environments. The point of this is, if you look at the bottom, it says SLO score, service level objective, meaning like what's the uptime of my application, what's the health of my application. And so as you can see, in real time, it's monitoring the environment, and it's monitoring your applications that you've put there. So right now, let's say you're in GitHub Actions and you want to deploy something. Well, you say you will call a command. It will trigger some other external system to then do the deploy and manage that, and and that other system will know about production. But your pipelines technology will not, because it's a general purpose tool. It's not deeply integrated into your cluster. It's not running. GitHub Actions is not running inside your cluster for your weird applications. It's a very separate, isolated system. Whereas the difference between these open source tools is they're running inside your cluster, or at least they're talking to your cluster. So your CI and CD systems are deeply integrated to the target environment in which, because they're all cloud native. And so I hope that makes sense when I'm emphasizing that. And so anyway, the purpose of this tool is this is a screenshot, is just to show you that it's listening and observing your environment. Now, when I said it integrates your tools, you can Kepton are saying bring your own tools. So bring Helm. So from the top left to the right, you've got Helm, Argo, Jenkins, Prometheus. You've got Dynatrace, Apache, Slack, Datadog, like everything, all the monitoring tools like Prometheus and New Relic and Datadog, to all the CI tools and CD tools like Argo and Jenkins X and classic Jenkins and others. So really bring your stuff, and you don't need to rebuild your stuff to get advantage of the modern features that we can get from Kepton. This is an example of end to end. On the very, very, very bottom left, you'll see a user, and number one, they push something up, which is like a Docker image, so that your CI pipeline has passed, is good, and you pushed your image up, right? And it's now the master image, or it's the new version of the software, and then that pushes it up to a container registry, which is GitOps happening. So GitOps basically the Kepton listener will listen for changes on your repository to say, hey, have you changed any versions? And it will go yes, and it will do all this stuff, right? That's not that important. What is more important is the right-hand side. So number 4 is done a deploy, and you run a test suite. Again, this is a Kepton workflow. So you're saying do a deploy, and then you're saying run the test suite. Now, Kepton will not actually run the test suite. It will trigger something, and that will run the test suite. For example, your Jenkins pipeline or your whatever CI tool you've got, it will run. It will execute something. Yes, you don't need other systems. You can just do everything in Kepton, right? But because not many people are using it, there's a high chance you're going to have existing stuff that you need to keep, and don't want to change. And so that's why I'm emphasizing kind of reusability. But to be clear, you don't have to bring these other tools. You can do everything in Kepton anyway, just like you would do it inside of Argo or GitHub Actions, right? Anyway, so it runs your test suite, but this is where it gets very different again. Monitoring feedback. So if I have deployed a feature to a security environment or a load testing or performance testing environment, I want to see how my system is performing differently to what it did before. That could be production, or it could just be a special environment. But on the right hand side, you'll see it says monitoring provider. So that is what you're using. So if you've got Prometheus on your Relic or whatever, those things are Captain's going to talk to them and ask them questions and look at and observe and monitor the health. And now within Captain, we configure the system, right? We configure the system, with YAML files and config files to say, hey, Captain, in the event that you see something like monitoring feedback, like number 9 here, right? Like, oh, there's a concern here. Then you can tell it what to do automatically, or not. It will make you realize that, and it will go on Slack, or it will prompt you to say, hey, we have noticed a problem. What would you like to roll back? Or it can do automated rollbacks, for example. And so if you think about it, the system that's in charge of deploying the software is also now the system that is integrated with the health of what happened after you deployed. And Captain will just monitor that, and you'll set the thresholds. Now, companies still have this stuff at the moment. For example, you still have Prometheus, or you still have New Relic, but those systems are not integrated back into your CD tool to do things with your production environments. And so, in effect, when a problem happens and you've got like an alert, right? That's what we do, right? We configure alerts, thresholds, and all that. But when that happens, it just goes, hey, there's a problem. But the human beings still have to come and look at the problem, assess what the problem is, and then make a decision on what we do about it next. And it's a very slow way to react, right? And so what the change here is with Captain is if something happens, you hit certain thresholds like response times go down, or the RAM or the CPU starts spiking up by a certain percentage or whatever that is. When Captain notices that, then you can tell it what to do, and it will automatically do stuff for you. And that's the change. It will automatically roll back based on whatever thresholds happen. So this is Captain. It's here in the market. It's created by a company called Dynatrace. You may have heard of Dynatrace, but not heard of Captain yet because it's relatively new. But Dynatrace are very well respected in the industry. They build excellent tooling, and I highly, highly recommend you check this out. Again, it's all cloud native. You can throw it on any cluster. You can create your own local cluster, or you can get a free one on the web or something like that. So, yeah. Now, obviously, from a testing perspective of this conference, like I have different talks that I do, right? I have CD talks, I have CI talks and stuff. So we're taking it from different angles, but ultimately, number 5 here, whether it's Captain or Argo or Flux, you create your own test suites that you normally have, but these are just small pieces now of a larger workflow, right? Anyway, so that is the end of the present, and we're going to move to the future. What to expect now in the future? So, opinionated tooling, but that facilitates unopinionated tooling. So not general purpose solutions like, say, Circle CI, but more things like Argo and Flux, right? You're going to see more and more of that unopinionated tools that you can configure. Argo CD is driving us into the future with event-driven pipelines, and Captain is becoming the control plane, which is an integration of all of our tools. And something that's being worked on right now that's not live yet, not production, is something called FSA, which is Flux Subsystem for Argo. So the future of continuous delivery is not one tool, it's all of the tools talking together, adopting a standard, and being able to communicate with each other, right? So you can have some bits over here in one technology, and that's cool. They can talk to each other, and you don't have to know how that works because we're coming together as a community, right? The Continuous Delivery Foundation facilitating that as well. And this means that you can, like Argo can then tell Flux to do tasks, and then Flux will do things and come back up to the Argo because, again, Flux is deeply integrated, and it will do things very, very good that other tools cannot. So I don't have much to say about that, but if you're curious, go and research that, because some companies right now, they have Argo or they have Flux, but they cannot have both. And so this lets you have both. And so that's why I want to highlight it. The CD in the future, the CD Foundation, it's split into six, which is a special interest group. This is how the Linux Foundation works. This is how Kubernetes works, right? So Kubernetes has 6 people focusing on networking, security, loads of other topics around software, right? And so the CD Foundation, we have 3 SIGs, which is the interoperability SIG, which is the cross communication between systems, right? Like I mentioned, systems be able to talk to each other now, and have that, as well as the events SIG, which is standardizing CD systems and the events that they produce. I touched on it slightly before, but the community is moving forward to event-driven pipeline architecture. That I'm going to talk about that next. And there's a thing called MLOps SIG. I won't go into much detail about that right now because of time. But if you're into ML or AI or something like that, have a look and see what they're up to. That's what I recommend. So this is what you're going to get in the future. This is where things are happening. So pipelines were traditionally webhook based, and there were one single big, unit. But we're on the edge of reinventing what is a pipeline, right? And we've had to do that for the previous years because of the shift to distributed systems and microservice architectures. We are now reinventing what is a pipeline, and it's becoming not a pipeline; it's a workflow and but no more notably events. So the third point here is splitting of pipelines into small pipelines. So think of a pipeline that has 10 steps. You're not going to have that anymore, and when they're coming into the future, you're going to have 10 pipelines, but we're not going to call them pipelines anymore. But they're going to have 10 things, and then in the future, you can just put those 10 things together, right? Solving things like reusability of code or reusability of tasks, and the compositions of the same things, but in different contexts, because like we're dealing with 10, 20, 50 different applications now. And lastly, like pipelines will no longer deploy the apps; they will trigger an event. So okay, I'm reading the questions you see as they come through. So distracted, but pipelines will no longer deploy apps; they will trigger events. So what I mean by that is, right now in your pipeline, you're like Ansible deploy or AWS deploy or something, or Kubernetes Go. But what's going to change is it's just going to emit an event that says start a deploy, and the pipeline is finished, right? And there's something else will be listening for that event, another pipeline or another workflow or something, and that will pick that up and that will handle that. And so we're shifting to asynchronous systems and event, and we have to do asynchronous because we've got all these moving parts. One single pipeline no longer works, right? You need that. Now, an example of an event-based pipeline architecture, which you're going to see more and more into the future, is because that's being worked on right now by the different teams and the CD Foundation, is events. So from the software world, we do consumers and producers and things like that, right? We're taking all of that knowledge and that architecture advancement from software world into CD world. So it's going to emit events now. So you push in it, you emit an event, and someone listens for an event. And so you'll basically, your pipeline will just be a wired up of wire up the different parts, right? And so I scan a Docker image. Okay, it failed. Something will happen. It passed. Okay, moving on. So that's where you're going to start moving towards more and more. So keep look out for this. But the good news is Argo has Argo events. You can already start to do this right now, right? To take advantage of greater flexibility and greater adaptability for building complex or systems and workflows. So if you're interested in this, like I said, Argo are pushing the envelope, and they are the innovation, a good innovative source. So go and look at Argo events. It's already in production. It's already stable. You can start using it, right? But more and more technologies will catch up with Argo, and they will have those feature sets as well. That's all I have now, time-wise, for this talk. But of course, you can find me on LinkedIn, Twitter. You can email me, and I've got some questions here on the chat that I'm going to try and answer as well. Hi, Wim.
Yeah.
Hi.
Thank you for your talk. I'm going to be honest, I didn't understand much of it because I'm not into CI/CD. That's not my current position. I'm just training people. But I think for the people that did know what you were talking about, it was very interesting. You can also see that from the questions. If there are other questions, people can always contact you. I think we have time for one question, and I'm going to take the one that is most popular from the Q&A section, because people upvoted it to being the most popular one. And that's the one about your UK government example that you've presented in the beginning of the presentation. How did you bring down build time from an hour and a half to 12 minutes?
So I do other talks, I do workshops as well, right? And I teach people the skills, how to do this, and I teach people. So I'm going to go all the way back roughly to slides. Can you still see my slides? Yeah, they're shading. Yeah. Do you see this? Yeah. I have a full talk on this. I give this talk at conferences. You see, I teach people as a full slide how to do this, right? But I also do hands-on training as well. So if you're wanting that kind of stuff, if you're in a company right now and you have a long pipeline and you have slow stuff, you can get in touch with myself and my team, and we can, come into your organizations and support you on fixing stuff. To try to answer the question, it's not one thing, right? It's like 10 or 15 different things I've done, right? That speed up over time. On the right hand side, you will see different test suites. So those are all in parallel. You cannot do these easy. This is Jenkins. This is why it works, because it's so powerful. I can do what I want, and I can create the hardware I want at any point in time. I control the hardware, you see. So in this case, it's not scaling vertically with loads and loads of little containers and loads of little parallel workers. That isn't going to work. And that's what you get when you use the kind of cloud systems, Circle CIs. That's what they make you work like. This is one machine with 32 gigs of RAM. It's an AWS Spot instance, so it's super cheap. It comes up instantly, and I get 32 gigs of RAM, and I get maybe like 18 cores, 16 cores of CPU. And when I'm building this, I'm looking at the CPU utilization, and I'm seeing, are we hitting that? Do we need to add more cores? So it's not just about approach and changing your pipeline and your test suites. It's also about understanding the hardware underneath that as well. And with systems like Jenkins, you get to control everything around what you want. You can tell the AWS plugin for Jenkins, hey, I want these specs for project A, and for project B, I don't have this stuff, so I want a different spec, a smaller machine, and it will, depending on the repository you're pushing to, it will spin up different machines for you. So number one is hardware. Number two is probably this is on the one machine. I'm not using extra machines. So when I download the code once. When I on the left side it says Docker build. Well, it says Docker build, right? So Docker build in the center. I'm building 5 images in one time in parallel across 16 cores, right? But the important thing is when I have that image, I can use it immediately because it's on the same machine. If you're using GitHub Actions and other systems, they'll make you use different machines, right, for parallelization. So you don't have the image on those machines. So you have to build the image, then push the image up, then you have to pull that image down onto all the other machines to then use these images to run your test suites. So that's time. And so again, that's one of many techniques where you can save time by using one machine with lots of hardware, and it's instantaneous. As soon as that build is complete, I can immediately begin using that. Another technique is, parallelizing your test suites, right? If you have a test suite and it's got 1,000 tests, it takes 30 minutes to run. Try to parallelize that and try to get that down from 30 minutes, maybe down to 20, perhaps. What I find a lot is test suites that were not created with parallelization from the beginning are not very compatible with being parallelized because they will just blow up, right? And so another part of my talks and my training packages around this is called, I call it test suite segmentation. Segmentation is to take something and break it down into small segments. And so if I have I have 1,000 tests and you cannot run them in parallel because it just, it blows up and the database is all messed up, then I will take your test suite of 1,000 tests and I will segment that into 5 sections of 200. And I will create a little label around each of the 200. So label 1, 2, 3, 4, and 5. And they're going to have their own databases, right? But inside of that segment, it can be parallelized. Like the accounting system, if the accounting tests, if you run them at the same time as the payment things, it will get confused. It will blow up and it will not work. But if I isolate them using Docker and Docker containers, they will have their own database. And so they're working in complete isolation. But inside that segment, they're all parallelized tests. And so you can take something that takes 1 hour. And if you have 5 you split into 5, you're going from 1 hour to, down to, 15 minutes, 12 minutes in theory, right? So that's one of the many techniques I use. And that's so, yeah, it's another talk in itself. It's a full talk, and it's a full 1 to 3 day training course as well that we do to help. So I hope that answered your question, Wim, and the others.
Yeah, it's very interesting. And bringing in parallelism, I remember I had some courses on that 15 years ago. So it's still being used, luckily. Thank you, Paul. Thank you, all participants. It's time for lunch break, and we will see each other again in an hour at 2:40 for a talk from Scott McAllister. There was a reshuffle in the program, so it's a pre-recorded session, and Scott will not be present, so there's no option to present, to ask questions, sorry. But I hope you will still be present, as it will again be a very interesting talk in the automation track. Again, Paul, thank you very much. I think if there are any more questions, you can contact Paul to get an answer. I think he has a lot of things to tell you. I think he has a lot of interesting stuff to teach you as well. So good luck.
You can find me on Twitter or whatever you like. But you can any questions you want to know, just ask them there, and I can reply.
Yeah.
Cool.
And for each and every one of you, have a great lunch, and see you in an hour.